Computers use RAM for storing data that is currently used by the processor. RAM is the fastest storage type in a personal computer. When comparing memory modules of different types, such as SDRAM or DDR2 or DDR3, or even when comparing memory modules of the same type, all memory is not created equal. Some memory modules are faster than other modules. As you talk about the speed of a memory module, you need to be aware of the following terms. The first term that is sometimes used to designate a speed is the frequency. The frequency describes how fast the clock cycle runs. And when talking about a clock cycle, there's actually two different measurements we need to be aware of. One of those is the bus clock, and the other one is the internal clock of the memory module itself. When you talk about the clock cycle, you might think of people playing jump rope. They have the rope strung between them and a third person is jumping. The clock cycle refers to how fast the rope rotates. And as memory operates, it needs to send and receive data in time with the rotation of the clock cycle. For example, if the person jumping the rope were to jump at the wrong time, the rope would hit that person. The same thing with the clock cycle. The bus is operating at a certain cycle, a certain timing. You might even think about it as a rhythm, like a beat on music. As the memory operates, the communication between the memory and the bus needs to occur on these regular cycles. The bus is set to operate at a certain frequency. For example, maybe 1000 megahertz. Memory often has a lower internal frequency than the bus frequency, but is always a multiple of the bus frequency. So for instance, maybe the memory module operates only at 200 megahertz. So it is actually operating slower than the bus speed. So in this case, the bus clock is operating at 5 times the speed of the internal memory clock. This is important, for instance, in this case, for every cycle of the internal memory, I can actually send 5 different instructions from the system bus. So when we talk about the speed of the memory is often matched to the bus clock. However, the internal operating speed of the memory might be slower as a multiple of the bus clock. The memory must match the bus clock, but also has its own internal frequency. What makes this confusing is that when you say how fast is that memory, some specifications may refer to the bus clock that the memory matches, and some specifications may refer to the internal clock that the memory uses. The second term that we might use in describing the speed of a memory is the bandwidth. The bandwidth describes the amount of data that can be sent, and typically is expressed in a unit of megabytes per second. So for example, one memory module might be rated at 100 megabytes per second, where a different module might be able to receive 200 megabytes per second worth of data. The increase in the bandwidth of the memory is often received by increasing the bus speed so that more multiples of the internal speed can be received on a single cycle. Remember that DDR memory doubles the bandwidth of SDRAM, and it does this by sending multiple data sets per clock cycle. DDR2 memory doubles the bandwidth of DDR memory, again by doubling the amount of data that is sent within a clock cycle. So when we talk about the speed of a memory, we might be talking about the frequency at which it operates, or we might be talking about the amount of data that can be sent. In most cases, the term speed should better describe the bandwidth, because bandwidth is always comparable. A memory module that can accept 200 megabytes per second of data is always faster than one that can accept 100 megabytes per second of data. However, when you're talking at frequency, sometimes a memory module with an internal frequency of 166 megahertz might actually outperform a memory module that operates at 200 megahertz internally. It might do this because the bus speed could be higher, or the amount of data it accepts per memory cycle would be higher. However, on many exams, when they ask about the speed of a memory module, they may actually be referring to the frequency and not the overall bandwidth. The speed of a memory module is typically identified by a rating number. Let's look at several designations for identifying the memory speed. The first designation applies to SDRAM. SDRAM was originally rated according to the bus speed of the memory, and it always had a designation of PC followed by a number, such as 33 or 66. And this number again designated the bus speed that the memory was matched to. SDRAM ratings typically go up to PC 166, or in other words, a bus speed of 166 MHz. When DDR-RAM was introduced, they kept the PC designation for a while. However, to communicate the idea that DDR-RAM doubles the bandwidth of SDRAM, the PC designation was doubled to designate twice the speed of the bus. So the PC designation is the bus speed times 2, the 2 coming from the doubling of the multiple instructions per clock cycle. So for instance, a PC 200 designation operates at a bus speed of 100 MHz, but it was called 200 to communicate that double the amount of data was being sent within that same bus cycle. So for instance, a PC 100 designation for SDRAM operates at the same frequency as a PC 200 designation. However, the PC 200 memory can move twice the amount of data within the same bus cycle. To further complicate things, as DDR memory evolved, the PC designation was changed to no longer identify twice the bus speed, but rather to identify the bandwidth. So a PC designation of PC 1600 does not mean that the bus is operating at 800 MHz. Instead, it means that it is capable of sending 1600 megabytes per second worth of data. And in fact, a PC 200 rating is equivalent to a PC 1600 rating, the only difference being the amount of zeros. If you had to tell the difference apart, you might ask yourself, does the number designate the bus speed times 2, or does it designate the bandwidth? Currently, all modules that are rated with a PC rating identify the bandwidth. However, as you're mixing and matching older modules and trying to compare the speeds, you'll need to be aware that current designations identify the bandwidth, whereas older specifications identify frequency. With the introduction of the new PC rating that identified the bandwidth, they instead used a new rating of DDR to identify the frequency. So an older designation of PC 200 is equivalent to the newer designation of DDR 200, which is equivalent to the PC 1600 designation. Newer memory modules will not use this older style, so for instance, you may see a PC 3200 memory module, which also has a designation of DDR 400. Again, 3200 identifying the bandwidth, whereas DDR 400 identifying the bus speed multiplied by 2. So in this case, the bus speed would be 200 MHz. Newer designations for DDR2 and DDR3 memory follows these same conventions. The PC designation identifying bandwidth, and the DDR, either 2 or 3, identifying the frequency. So with all newer memory modules, you can take the PC number in every case and compare it between DDR, DDR2, and DDR3. So for instance, if I had a DDR3 module that operates at PC3 6400, or if I had a DDR2 module that operates at PC2 6400, you might ask yourself which memory module is faster. In this case, we are comparing bandwidth, and the bandwidth is equivalent. Let's say, for instance, I am comparing PC3 6400 with PC2 8500. In this case, I have an older standard of memory module, DDR2, that can move 8500 megabytes per second of data, which would make it faster than the PC3 designation of 6400. Frequency, however, is further complicated. Looking at my frequency designation, if I have a DDR2 module with an 800 designation, this means that the bus clock is operating at 400 megahertz. Again, the designation is double the bus clock. If I have a DDR3 module, also operating at 800, these are equivalent in speed because they are operating at the same frequency. So let's look at a couple of examples. Let's say we have PC166 memory, and we want to compare that to PC266 memory, and we're going to also compare that to DDR2 400 memory and DDR3 400 memory. So the question is, which of these memory modules is the fastest? Well, in this case, all of these designations are identifying the frequency of the system bus. So a straight number comparison would tell me that DDR2 and DDR3 are equivalent in speed, and both are faster than these two designations. And let's say my second memory module has a PC rating of PC1600. In this case, if I were simply comparing the values, I might think that PC1600 is faster than the DDR2 400. But remember, this is a case where the PC designation is now identifying bandwidth instead of frequency. I'm not doing an apples-to-apples comparison. Instead, I'm comparing the bandwidth in one case to the frequency in the other cases. So to make this comparison, I need to convert the bandwidth into a frequency value. And I do that by dividing the frequency by 8, which gives me a PC200 rating. Or it might also be called a DDR200 rating. Now I can make my frequency comparisons and see that DDR200 is slower than the DDR400. Let's replace my last memory module with a PC3 8500 designation. In this case, I need to answer the question, which memory is faster? Again, in some cases I'm using frequency, in other cases I'm using bandwidth. I can immediately identify that the bandwidth of the PC3 module is higher than the bandwidth of the PC1600 module. But to make these comparisons, I would need to convert this again to a frequency value, which is dividing it by 8, which gives me a DDR3 designation of 1066. So in this case, when comparing the frequency, my DDR3 module is faster than my DDR2 400 module. Or in other words, a memory module with a PC3 8500 designation is faster than the DDR2 400 designation. So the main thing to remember when comparing memory modules is to ask yourself, am I comparing the frequency or the bandwidth? Or is there some odd combination of the two? Ideally, all ratings will be either frequency or bandwidth. But if you need to convert between one or the other, simply divide the bandwidth by 8 to get the equivalent frequency. In addition to frequency and bandwidth, there are two other factors that you might hear when describing memory, and these are the timings and the latency. The latency is the amount of delay that occurs between a read request and the actual return of that data. Timings are often expressed as a series of numbers for memory. And it might be something like this, 7-6-6-6. Each of these numbers stands for a different type of delay. However, in most cases, you'll typically only be worried about the CAS latency or the CAS latency, sometimes also called the CL. The CL identifies the amount of delay between a read request and the actual return of that data. So for instance, when a memory module receives a read request on the module, it takes some time for the memory module to actually access the data and then output that data onto the pins of the module. And that amount of delay is referred to as the CAS latency. The CAS latency is typically the first of these 4 numbers. These additional numbers identify other types of delay for other types of operations. When you configure a memory module, you need to take into account these delays, and those are typically done automatically. A special chip on the memory module identifies the timing characteristics of that module, and the motherboard is configured to use those timing values when communicating with the memory. When you purchase memory, you might be able to see all of these timings listed, or you might simply see a CL value listed for the memory. Let's say you have a DDR3 module with a CAS latency of 7 and a second module with a CAS latency of 6. In this case, you would say that the CL6 module is faster because it has a shorter amount of delay within the memory module itself. So in general, the lower the CL value, the less delay, and in some degree, the faster the memory. However, if I have a DDR2 module with a CAS latency of 7, the actual delay of this module might be less than the delay associated with my DDR3 module at a lower CL value. The problem is that the latency values cannot be compared directly between the 2 different memory modules. There are other factors that are taken into account when computing this number besides simply a time value of the amount of time between the submission of the request and the receipt of the data. So as a rule of thumb, when I'm comparing the CL values within a certain type of memory module, I can simply choose the lowest value to get the fastest memory. When I'm comparing across modules, that doesn't hold, and I'd need to do more complex calculations to identify which memory might have less delay. In most cases, however, you'll have to choose either DDR2 or DDR3 based on the motherboard support. So when we talk about memory speed, it's important to identify what we mean when we're talking about the speed. Is it the frequency of the memory, the amount of bandwidth that the memory can transfer within a given time period, or is it perhaps the amount of delay associated with read and write operations within the memory? In many cases, on an exam, you might be just looking at the frequency. However, this is often inadequate to identify the real performance of the memory. The best measure is the bandwidth, which identifies the amount of memory that can be transferred to the memory module. As we've seen, DDR3 memory typically transfers more in the same clock cycle than DDR2 memory, so it is considered faster. However, they may be operating at the same clock frequency.